paste, RSP2, RSP3. Okay. Now we're almost done. Just a couple of things we need to do. Number one, for gender, we need to give them those numbers. If you remember, right? So for example, for gender, we have only 2, and so gender remains gender, age remains age, education remains education, and occupation remains occupation. Okay. Okay. I'm not saving this file because I already have saved this file. So I just want to show you how to set that up. Now we're done with the name. Names are fine. Numeric values are fine. The width is up to us. Decimal, as of now, we don't need to check decimal. At least at this stage, we don't need any change in decimal. We can keep it to 0. Labels for our reporting. These labels will appear. It's just the same like we do in Amos and Smart PLS. There are 2 views. One is for the report, one is for the model. Okay, so this is for the data that we'll see, and this is for the reporting. Okay, now this is very important for SPSS. We need to check we need to tell SPSS what type of data it is. If you remember, we have taken data on Likert scale. I show you on Likert scale. So we need to tell SPSS that data is on Likert scale. So we know that on mostly people use 1 for strongly disagree. Okay, I'm hoping that I'm visible to all of you. My screen is visible to all of you.
Yes.
Okay, thank you. Okay. So that doesn't mean that you can only do Likert scale. Any Likert type scale you can do. Any Likert type scale. So that could have any level, 5 level, 7 level, 9 level, 11 level, whatever number of levels you have, you can do it. And then strongly agree. Look, I did a spell check here. It says no problem with the spelling. Everything is fine. I said okay. And but here's the thing. I've set it up only for 1, and I have until here. I have all this Likert scale data. So what I'll do, I'll go here. Sorry, we'll go here and copy, and then we'll go down here and select, and then right and paste. Now we're done. Look, you set it up for all this here except for gender. Now we need to set up for our. We need to set up according to the type of how we want to do that. Mostly usually gender is a categorical variable, and age, education, occupation, because it has multiple levels, we measure them on ordinal level, right? If you remember, there are a couple of type of variable, the ratio variable, the ordinal variable, the categorical variable. So we need to tell SPSS what type of data is this age, because SPSS only has number here. SPSS does not know what age means here, or what age 1 mean, what 2 mean.
Recording stopped.
So we need to tell this. So what we'll do, we'll go here, age, we'll check age, sorry, we'll go here, age, and assuming that number 1 is for, let's say for 18 to 27. Okay, 1. 2 is somebody 28 to 37. 2, 3, we have somebody 38 to 47, for example, right? And 4 is anybody who's above 47, right? 47 and above, let's say, and above. Okay. Okay. So let's take a look at, we have how many levels in the age? We have 1, 2, 3, 1, 2, 3. We have 4. We have 4. No, we don't have 4 actually. We just need to remove it. Okay. So let's go here and just remove it. Okay, so we are set up. We're done with this. Okay, education. So let's say somebody has a bachelor degree, somebody has a 10th grade, let's say 10th grade. Okay, 2 bachelor, let's say 3 masters. Okay, okay, let's take a look at how many we have. Education, we have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, I have only taken 3 levels here. So you can take more levels, no problem at all. And then we go to occupation, and then occupation. So let's say I have, actually I remember I have taken 8. So number 1 is a student, okay. Number 2 is somebody is a doctor, let's say. Number 3, let's say somebody is accountant. Say number 4 is for businessman, okay. Number 5 is for, let's say, for educationist. Number 6 is, let's say, for dentist. Now, dentists usually, even though they're doctor, but they like to call themselves dentist, not doctor. Okay, 7.
Recording in progress.
Housewife, let's say housewife. Number 8, let's say, is retired. Somebody's retired. Okay, so we are done. So we have already told what type of scale we have taken to SPSS to measure this data. Now the last thing is left, and that is telling. Now we know we have already told what type of scale we have, what type of the what we call the levels of scale. We have told the level of scale. However, we still need to tell SPSS what type of data we consider it. So if you realize in SPSS, whenever we have this type of constructs, or these constructs data, especially these constructs, concept, satisfaction, loyalty, retention rate, engagement, kind of thing, usually we have, if you have used this type of 2.3, 3, 2, 4, 5, 6, 7, 8, 9, 10 items, that means it's a scale data. It's a scale data we have taken. And we'll copy scale data. So let's copy here. And we'll go down to response and paste. Okay, so we're done with scale. Now SPSS knows the scale. Now we are faced with age. We need to tell what type of data is this. And we are telling this is nominal. Nominal means categorical data. Nominal data. Age is fine. However, education has moved into levels. That means it has ordinal, right? So we'll call it ordinal. Okay. So if we are done with this part, we are ready to go. We are ready to run our analysis. We are ready to run our analysis. That means we are ready to do our. So we're done with setting up, specifying, importing data, setting up view, variable view. We understand setting up variable view. And we have also done designated variable type. We have designated them. Now we need to move, and that belongs to data screening. So let me close this sheet because I already have this set up this sheet somewhere. You want to do that? No. Okay. Let's close this file. Okay. Let's close this output file here. Okay. So this is the file. And if you look at this, the name of this file is bit missing value. The first stage, the first thing we need to do, if I can show you here, when we start doing data screening, keep in mind, Amos and Smart PLS or these type of software, mostly, not all, some of them actually allow you to do that. They do not allow you to do the data screening, right? That means if there's something wrong, you can't get that right, number one. And even though they may have a treatment available, but that means they will run the data as it is, keeping in mind that, oh, there are some missing value, but they will not fix that missing value issue 100%. In comparison, SPSS allows you to do a number of things, and one of them is we can, number one, we can check missing value at any, and then we can treat it accordingly. So how we can treat it? Let's do this. Okay, let's go here. Number one, So we understand this variable view, right? And take a look at here. I've already set this up here. And take a look at here what I've done. Even though I have some extra variable, and I'll show you what I've done here. So number one thing, what I want to do before I do screening, I need to show you this. Look here. I have another set of data going here. Okay, don't worry about that. I'll show you later. So number one, let's go to screening. Look here, whenever we're in SPSS and we need to run analysis, we don't go to variable view. Once you have set up the data, we don't need to go to variable view. We need to remain in data view. And now here you see file, edit, like any software, data, transform, analyze, graph. There are multiple things you can do. Most of the analysis are run from here and analyzed, and most of the data changing and some other type of treatment are done here. Okay, so number one thing, like I said, let's start doing with the screening. For the screening, let's go to analysis, analyze, descriptive, analyze, descriptive, and let's go to frequency. And I hope you all are able to follow me. Analyze, descriptive, and frequency. Okay, so now I have how many variables? These are extra variables. I won't care about that. For now, we'll just ignore them. Okay, so let's go here. Let's select all of our data, Control Shift, just Shift actually. So I selected here, and then I'll press Shift, and then I'll click again. Now I'm able to select all. I can drop them here, or I can simply select them. Okay. So here I have given these, moving this variable to here, that means I'm telling SPSS to please consider these variables for whatever next stage I'm going to ask it to do. Statistics, just leave it as it is. Chart, leave it as it is. Oh, okay. Where am I? Frequency. Just leave it as it is. Everything leave as it is. Don't do anything. Display frequency table. No, I don't need frequency table. Just click OK. So I went here, analyze, then I went to descriptive, and then I went to frequency, right? And then I selected. I actually unchecked it. Anything which is, whenever you go into any of this dialog box, there's a reset, and it will reset everything. So I resetted it, and now after resetting, everything is back to 0. I have to set up everything all again. So here, and then by default, it shows display frequency table. I don't need frequency table for now. Let's go OK. Okay. So as a result, I am seeing some type of analysis, some type of statistical analysis SPSS has done. And if you look at here, SPSS is showing me two types of data. Number one, SPSS is showing me, let me go here. Okay. SPSS is showing me here valid. They're saying that total number of the data is 208, just for syntax, 208, 208, 208. Look, one of my column has 207. It doesn't have 208. And one of them is 205. One of them likewise. Why is it happening? It is happening because there's some missing value in my data. And that's the first stage of screening data, missing value. It has 1, it has 3. Now, missing values are good? No, they're not good. Even though we can have missing value in data, but if you remember, I talked about this in Smart Killers workshop, that if our data has more than 5%, total data has more than 5%, missing values, that's a huge problem. It shouldn't be. So ideally what you should be doing is that try to keep it as minimum as possible. And if you identify, when you're doing the screening of your data, before you go into MS, you put your data into MS or into Smart PLS or any other software, you want to do some type of screening, and SPSS is really good for that screening. And the first stage of that screening is identifying if there are any missing value. So we know there are missing values. We know there are missing values. Okay, so what do? Let's close it here. Let's treat these missing values. We have a solution for missing values. Let's go here. Okay. So first we went to analyze. Analyze is the place where we mostly run our analysis from, and now we're going to transform. To transform or replace missing value, and then there you go. Right? Now I need to select all those variables, and I know my variable starts from here and up to here. Select all of them here, put them here, and then click on any of them. And look what it's going to do. It is asking me what type of treatment you want. Do you want a series mean? Series mean all these series mean. That means if one, right? That's a series mean, right? If one, I think series referring to, if I'm not sure, if I'm not wrong, this is for raw. So it will take the mean value, the average value of this raw. Let's say there's one, somebody's missing here, any of this data missing here. So it'll take the average value of 1, and whatever the average value comes out, it will put there. Other way around is saying mean value of nearby points. The reality is that the both are okay. There's nothing wrong. There's nothing wrong. I would rather stick to mean of nearby points, but there's a lot of people who prefer series mean, and it doesn't really much matter. Okay, so let's take series mean here. And okay, look what is happening here. It's gonna change the name of these variables. So as soon as I do it, it will create. Let me go here. Let me do it here. Okay. These were some extra variable in our data. Clear it. Save it. Every time you will save it, you'll do. There's
recording stopped.
There's a dialog will start. Okay. So I'm going here, analyze, again, transform, replace missing values, and then I select it here, and then click on anyone, series mean. And look, it's going to create actually a new variable with a different name. Age will become age this, and this will become this. And that new data on the same sheet would not have this problem. So let's go OK. Let's click OK. So as soon as I clicked OK, it is showing me what it did. That showed that it created new variable, number one. Those older variables are there. The new variable should be on our sheet. And it's showing me how many missing values are there and which one of them it treated, and showing me the number of valid cases. Finally, all are 208, which is the actual number for our sample in this sheet. Let's close it. Okay, let's click it here. Look, we have the new variables here. And all these, so what it has done, it has duplicated all of this data from here till here. And this data doesn't have those, this data does not have those missing values. And let's check them if this data has those missing values or not. If the SPSS has properly treated those missing values. So this is our older data, and this is our SME, that means mean value. So let's select from here and go here. This. Okay. And then display. Okay. And look, now our data doesn't have it. Now our data doesn't have this. Our data is all free of any missing value. And free of any missing value. Until to the end, occupation and everything. Okay. So we're done with the first part. The first part was that how to treat missing values. How to treat missing values. Okay. So let's go back. So we're done with the missing value, and now we're going to data normality. Now, why are we going to data normality? Why are we going to check data normality? We're going to check data normality because there are two types of tests called parametric tests and non-parametric tests. The reality is that most of the statistic tests are based on parametric. That means the basic assumption of those tests is that data is normally distributed. And I believe most of us understand what you mean by normally distributed. All right? And for normal distribution, in order to do that, we need to run different type of analysis. Even if you're putting your data, if you're going to run any non-parametric data, still it is recommended we have a look at whether our data
Assalamu alaikum, sir. কি স্যার? ও কোস্ট
if our data is too
ও আচ্ছা দেন কোস্ট বানায় দেন
it's
স্যার,
highly
দেন সমস্যা নাই।
left or
ও আচ্ছা 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 ঠিক আছে বুঝতে পারছি স্যার, কিন্তু আমি তো হোস্টেও নাই দেখলাম স্যার, আমি কোস্ট বানাবো কিভাবে? আচ্ছা 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 ঠিক আছে, এখন কি আপনাকে কোস্ট বানাই দেবো স্যার? ওকে ওকে, আসসালামু আলাইকুম।
you want to proceed? Yes. You want to close? Save? No. Let's say we don't want to close. I'll go here and I'll open another sheet that has with missing value is treated. Okay. Please allow me a minute. I'm opening the new data sheet. It's pretty slow. I hope you all are with me, are able to understand what I'm talking. Dr. Mehdi, is everyone good?
Yeah, it's fine.
All good, all good, all good.
Okay.
Yeah, sir. I think the session is not being recorded.
Yeah, Dr. Mehdi's session is not being recorded.
Yeah. I'm going to.
Okay. So now I have that file here, and if you look at there, I've just removed those files here, and now we're back to the same, but still this data has no missing value. It has already been treated. Now let's go to analyze. Let's see. See, we can do so much. We can do so much when it comes to normality of the data. There are a lot of tests we can run. Let's run explore. Let's go to analyze, descriptive, and explore. Analyze, descriptive, and explore, right? And we want to look at
recording in progress.
We want to look at our data is normal or not. Okay. Before we move on to testing the data, let me show you a couple of more things here. Okay. Look here, we have this data. Usually we run two types of data. There can be two types of analysis we can do in SPSS. Some of these analyses require us to have these items, one by one, these items separated. And some of these analyses may require us to take mean values of these items. That means whatever the mean value of this is, we'll take the mean value. So now how we can do it? So before we check whether the data is normal or not, let's do this. Let's go to transform, and we create new variable, and those variable will be actually the average of these. So average of all the responsive satisfaction one, that will be average. So we'll have average of all satisfaction. We'll have one column of average satisfaction values. We'll have one column of food quality average values. So let's do, how do we do that? So in some type of analysis and SPSS, we can run as it is. In some type of analysis, we need to have average. Let's call it mean value. Okay, so let's do it. Transform, compute. Okay, let's do this. Now, how are we going to do average? Very simple. So let's put it customer satisfaction CS, and I'm putting CS underscore M. There should be no space. Otherwise, there should be no space. I can't put like this, M, it will not accept it. It will not accept it. It will keep giving me error. M means mean value. Let's put it M a little bigger. Then I'll go here, statistics. I can do it manually as well, but let's do arithmetic. Okay, let's go to statistics. Where is statistics? Okay. And let's take mean value. So as soon as I click mean value, I see here. So let me take mean value of this now. Satisfaction. I'll just click next, comma, next, comma, next, comma, next. Okay, that's about it. I'll click OK. Click OK, and as soon as I clicked OK, it executed, and look here, it created a new variable, CS1, and this is actually the mean value. If you realize, this is the mean value. Look, I have a new variable here in my data CSM. So in some cases, we'll be using mean value, and in some type of analysis, we'll be using as it is, as we imported, as we collected the data. And I'll let you know where I'll do that. Okay, so let's do number one. Let's go back to transform, compute. So we are done with CS1. Let's go to FQ. FQ is right, and let's remove all of this. Again, click on mean. Now go to FQ1, FQ2, FQ3, FQ4, FQ5. Okay. And I'll do the same. Click OK. We already have the third variable, second variable. Let's go to the third variable here. Delete, mean value. The third variable is PV, receive value, PV. We have PV1. I'm sorry, guys, it's taking time, I know, but I just wanted to tell some of the basics of it. It was quite easy for me not to do it and just move on to next. But I wanted to help those people who have not used SPSS before, so I wanted to give them something basic. Okay, and then PVM, okay, the new variable has been created. Go back to, okay. Remove, which one is, and then we have ambience and responsibility. Only two are left. A and B, ambi, and then ambi1, ambi2, ambi3. I can do it manually as well. This will be able, I can do it with manually as well, not a big deal. But I just want to show you how software does it. Okay. And then okay. Now the fourth one has been generated. Let's do the last one. Let's do the last one. Compute variable. We don't need to with age, gender because they are already single value. They're already single value. Okay. So RSP is responsiveness. RSP is responsiveness. Responsiveness 1. Responsiveness 2. And then responsiveness 3, and then comma, responsiveness 4, and click OK. Okay, now we have, if you look here, let me save it first. Every time you save it, every time you do, this developing. Look here, we have the mean value of everything, and it's already scaled. Okay, we are good to go. Let's do, so now this will be very helpful for us. These values, these mean values will be very helpful for us when we move on to another level. We'll be doing regression and mediation and moderation within the regression. Okay, so let's do here. Let's go to analyze, let's go to descriptive, and let's go explore. Okay, and we know that we need to select only these 5 here, dependent. Okay, and then statistics, leave as it is, plot, okay, normality or test, stem, and let's see. Okay, so I've selected here histogram, stem and leave, I don't need that, I don't like it. And I've selected here, checked off normality plus with test, continue, and the option, I just leave it as it is and click OK. So what are the options? If you remember, we have multiple options. We have multiple ways of checking normality. The most common one is skewness and kurtosis. Skewness and kurtosis. Look here, the SPSS output is showing what it has done, the number of the responses, percentages, missing value 0, total, all is good. There's no missing value. So it's showing me mean value and a lot of median, variance. And look here, if I want to look at my data as normal or not, on the standard of skewness and kurtosis, there are two most common. Some people say, the one I follow is skewness and kurtosis both minus plus 1. Plus minus 1, this is the one I follow that, my skewness and kurtosis value should be within minus 1 and plus 1. However, there are other people who believe that 0.87 is a better way to do that. I do it 1. That means other people believe it's the minus and plus 0.87. Likewise, there are other group of people, group of scholars who believe that kurtosis, if it's between minus plus 3, just the kurtosis, not the skewness, that still data is normal. So according to this, our CS, customer satisfaction, this is normal here according to skewness and kurtosis. Likewise, skewness kurtosis here is normal. And again, skewness kurtosis is normal, PV and MB, it's normal, and it's normal here. Okay. Let's take a look at, there are other type of variables, there are other type of tests. The most they're also quite common with the scholars. They like to check, they like to test normality through using these Kolmogorov, I believe it's called Kolmogorov. That's some Russian name, I believe. Kolmogorov and Shapiro. And then there are scholars who do not like Kolmogorov, and let's call it KLM. They don't like KLM and they like Shapiro. On any standard, on any scale, even though skewness and kurtosis here shows that our data is normal, if you remember, usually if the significance value is less than 0.05, it's good. That means we usually accept our hypothesis in various other ANOVA regressions or even in structural question modeling. However, in here for normality, it's inverse. That means if the value is bigger than 0.05, then you can be sure your data is normal. And if you look at here, both tests here are showing that our data is normal, even though skewness and kurtosis do not say so. They show that our data is normal. So what to do? Well, this is what we can do. Okay. This is what we can do. We can have a look at, there are other people who believe that, we should always be visualizing our data instead of just trusting these tests. We should always be visualizing the data to see if our data is normal. And it looks like this data here looks like normal. QQ plot is like, the closer these dots are on the line, the more your normal data is. So for CS customer satisfaction, it looks a normal data, approximately, okay. And again, showing the box plot, that means there's no outliers here. Here, almost it looks okay. And then, this probably a little bit skewed. This is a little bit skewed. And can we change it? Okay, can we change it? Option, elements, interpretation line, close. Yeah. Can we draw a trend here? Okay. Yeah, this is a little bit skewed on the left side. Okay, let's go next. This is also, but this also almost this is normal. So what we are learning is this. What we're learning is that except for one of our variable in our study, the rest looks okay. This is the one looks, because if I draw a bell shape here, I'm trying to draw a bell shape here. How do I draw a bell shape? Option, trend line, trend line, trend line, trend line. Okay, I can't, trend line, where's trend line, trend line, trend line. Okay, I can't see as of now, trend line. Anyway, if I try to draw here, I'm pretty sure that this looks like a little bit left skewed data. That means this is a little bit, non-normal data. The rest looks okay. So now, if we have this problem, ideally what we should be doing is that we should be looking for outliers. And if you look here, this box plot doesn't show much of our outlier, right? Much of our outlier. Box plot doesn't show the outlier here. So we are done with, ideally what we can do, we can take a look at skewness and kurtosis. We can also look at KML and Shapiro, and histogram is extremely essential. We should be looking at histogram. If histogram shows our data is normal. If it's not normal, like I said, there are in secondary data they take log, and taking log is very easy. Go to transform. Go to let me close it. Taking log is very easy. You can take log from here, somewhere here you'll find log, log right here, log 10. But however, I'm not sure about that, because it's very common in secondary data research. They will take data. If the data is not normal, they will take log of it. As a result of taking log, a lot of data becomes normal. I haven't seen this practice in primary research, such as in questionnaire. So I won't recommend it unless you have investigated. There are other scholars who strongly against removing any type of data, even outlier, to normalize your data. They believe that that's the true representation of the population age, even though it goes against the center limit theorem. Okay, so we are done with. Let's go back. So we are done with two parts: setting a file, normality. We know how to check the normality of data, and then outliers. So Mahalanobis test. We'll be doing Mahalanobis. This is also called multivariate outlier. So you need to understand that there are two types of outlier testing I can do. Number one, outlier test I did with. I just did that where I tried to. Let me show you how can we do a simple one. Let's go to descriptive and let's go to explore and let's reset it. So if I want to check outliers, so let's see outliers right here. Continue. So where I went to analyze, descriptive, and explore. And then now I'm doing just for the customer satisfaction. Now look. Right? This is the box plot, right? It shows me there are no outliers. However, the problem with this approach is this: when we run the data, especially when we run the data in SPSS, in Smart PLS, we run the data all together. So if we check the outliers in each variable, the problem with this approach is that this is against the logic when we are running the data in PLSM all together. So we need to check the outliers, put it all together, and then checking which one is an outlier in our data. So for that, what we do, and it's a very popular one. We call it multivariate, outlier approach, in which we use all the data together. We put all the data together. We try to figure out whether our data is normal or not. So how do we check? Let's reset it. Okay. So how do we do Mahalanobis test? So I'm going to do now Mahalanobis test in order to check whether our data has any outlier. All right. There are other type of tests, but this is one of the most common one. So number one thing, what we want to do is let's go to analyze, regression. So I'm going to analyze and regression, and then I'm going to linear. Analyze, regression, linear for Mahalanobis. Okay, and I see this dialog box here. And then, and again, I'm taking the mean values. I'm not taking the mean data. I'm taking the mean value. I know customer satisfaction is my dependent variable. And I know these four are my independent variable. So I put them here, satisfaction here, and I go straight to save. I go straight to save, don't do anything, and then set Mahalanobis distance. Okay, I'll click continue, and as a result, and I'll click OK, we will see a new variable in our sheet. Close this, we don't need this as of now. Let's take a look. We have MAH1, this is the Mahalanobis score. However, in order to check whether this score is, tells us whether there is specific, raw data is what we call outlier, we need to do a couple of further tests. So let's do this. So we will take, we'll use chi-square values. We will use chi-square values. So I went here, transform, compute variable, and then I went here all, and then I'm selecting CDF. Basically, this is chi-square values, and I'm putting here what? Let's say probability. I'm putting a probability, right? And let's select this. Mahalanobis distance variable. I selected and it came out here. Now I need to test the degree of freedom, and we know our predictor of 4. There are some people.
Assalamualaikum Brahma. Oh, acha Brahma, ঠিক আছে. Assalamualaikum.
Now look here, I have another variable. So what it has done, let's go here, probability and decimal value, that's 3, 4. What it does, it has created probability value. Now the problem is that I have 200. I'll have to go each one by one to see which one is less than 0.001. Any value that is less than 0.01, we will consider that as outlier. So what if you have thousands of data? That will be very difficult. So we have a simpler way of doing it. So this, so we created probability value from this value, right? And this probability value we can further simplify. We can literally simplify by creating a p-value, and any p-value that is smaller than 0.01, we will know that is the outlier value. That is the outlier. So how do we do that? Let's go back to transform, compute variable, and let's reset it. Let's put it as a significance, right? Or p-value, significance p-value. So let's do this. Probability. I click on probability came out, and I say less than 0.001. And I say okay. Oh, okay. Let's put p-value. Okay, so now we have p-value here. So from p-value, any value that is less than 0.01, we'll know this is that will be. So let's go here. Cancel. Okay, we have increased the decimal to see this properly. Do we have any value less than 0.01? If that will become 1 automatically. So let's go here, actually make it 1. Do we see any 1 value here? No. If there were any outlier, that would be 1 here. We would see 1, literally 1, like this. And that will tell us, okay, this one is an outlier, and we'll simply remove it, because this often is the case that when we have an outlier in our data, that makes our data abnormal. That means that skews our data. So because we do have no outlier here, I wanted to create an outlier to show you, but however, coincidentally, it doesn't have any outlier. So we are sure that there is no outlier in our data, right? Okay, so let's go back. Let's go back here. Let me put it here. Let's go back. So what we have done. So in data screening, the first thing, missing value. We figured out how to identify missing value, and then we figured out how to Okay, and then we figured out how to do treatment of our missing value, and then we figured out how to check the normality, and now just ran the outliers test called Mahalanobis. And the last state that I'm going to do in our data screening part is common method bias. I have taken these types of data screening specific for our PhD and master's student, because I know mostly this type of data screening they are most concerned about, even though there are other type of data screening can be done, but I believe this is the most common one, and I've taken that one. So if you want to test common method bias, if you think your data may have common method bias, how can you check in SPSS? Well, in our Excel, in our Smart PLS workshop, I did it through, I showed you a full polarity assessment, and there's another one called marker variable, but those all are done in Amos or in Smart PLS. In SPSS, we can do the test called Harman single factor test, and we can do Harman single factor test in Amos as well, as far as I remember. Okay, now how do we do that? How do we do that? Look what I'm doing here. I am doing my analyze, and diamond reduction and factor. And now I'm not taking mean value. I can take, if you want to do that through mean value, you can, but for me, I would prefer this way. Some people prefer with mean value, right? And I'll show you both ways. Let's do this. I'll select all my items. I don't need to do for gender, age, and I'll put factor here. Look what I did. Analyze, factor reduction, diamond reduction, and factor. Okay. And then I'll go here, descriptive, leave as it is, no need to do anything. Extraction, I'll change this extraction principal component to principal access factoring, and I'll put fix here, and I'll put 1. Basically, I'm forcing my data to load into one factor, load into one variable, and then I'm trying to see if any of my item has explains variance larger than 50%, right? So that's all I'll do. Continue. So descriptive, I left as it is. Extraction, change it, and then 1. I don't need to do anything. Some people do the variable excitation. Even if I want to do that, I can, but I would rather have none. Continue. Okay. And I'll see if any of my variable explains more than 50% of the variance. None. When I tried to force my data, at the maximum one of my item was able to explain was 42%. Since it's less than 50%, I can say, as per the Harman single factor test, my data does not have the issue of common method bias, CMV or common method variance. Okay, let's do it another way. What if you don't believe in this way, even though I like this way, I prefer doing it this way. Okay, let's do analyze and then go back to factor, scale, go back to diamond reduction and then factor, and then reset it, And let's go back here. And now I'll be selecting those mean values that I've taken mean values. Just the mean value. That's it. Now look what happens. I do the same descriptive, leave as it is, extraction. I change it to principal accident, fix one, rest as it is, and then okay. Look what happens. Now it's showing me that one of my variable, one of my, the factor within my data is showing as high a variance as 57%. So according to this, my data, if I take the mean value, according to this, my data has the issue of CMB. However, like I said, I don't like it this way. I believe the other way. I believe I usually do with a single item, and according to that, my data does not have. Likewise, something very similar to that you can do in AMOS, and the rule is same. If any of our variable, if any of our item shows more than 50%, just remove it. Okay. You have to really go back and take a look at which items are creating certain CMB, and then probably remove them. Right? Okay. So let's go back.
Dr. Kahsif,
Yes.
can you hear me?
Yes.
Can you go for break 10 minutes, around 10 minutes?
Sure. We're done. We're done with
okay.
we're done with this part. That is clear.
Yeah.
Let's
Yeah,
go
sure.
to 10
Yeah,
minutes break. 10 minutes?
Yeah,
okay,
10
sure.
minutes.
Sure. Okay.
Hello. And how is going there?
बागुस बढ़िया है
I was say बढ़िया है.
सब
Yeah.
बढ़िया है
Long time no see you.
yes thank you for conducting this
Where is
excellent
your camera?
workshop.
I cannot see you.
You cannot see me.
Yeah, I cannot
Let's
see
turn
your
my-
face. Long time I did not. Yeah. Long time I did not see you.
Now
Oh,
I'm
great. Yeah. I'm here.
Dr. Mehdi, some people would
Yeah.
like to. Some
Yeah.
people would like to ask questions. So
Yeah, those who want to ask the question, please ask the Dr. Kahsif. He's here.
sure. Whoever wants to ask any questions.
Yeah, during break, if you have any questions, so you can ask Dr. Kahsif and he would like to answer your question. So don't feel shy, don't feel hesitant to ask any question.
Hear me?
Yeah,
Yes.
sure.
I have two questions. One that is it possible that we get more components than our constructs when we run EFA?
Yeah, when we run EFA, what to do with that? Sorry.
Is it possible that we get more components than our constructs? Suppose that if we have 5 constructs or 5 variables and we run EFA and we get more components, like 6 or 8, but we have 5 constants.
Yes, it's possible because that's we call factor, right?
Yes.
Okay, that's we call factor. Yeah, it's possible. Why not? If you just see that, what I did when I tried to run data reduction, actually this is EFA. If you remember, if you understand, I'm trying to do EFA here.
Yeah.
So, and I tried to, because I wanted to force it, and I said it no, cannot be more than 1. As a result, it tried to put everything into 1. So yes, why not? If you run EFA, actually in EFA you don't try to ask SPSS to how many factors are there. You just leave it to SPSS to decide. So it's possible that you have 5 variable or 5 dimension of one variable, and SPSS takes it as 7 dimension. It puts them into 7. It will see the variance whichever, if it finds that 7. In other words, 7 factors have very high variance, it will divide them into 7. This is possible. But here's the question. If SPSS divides into 7, should you consider it 7? That should be the real question.
Yes.
Right? No, you shouldn't. No, you shouldn't. Because SPSS is a software, it doesn't understand the conceptualization behind it. So you should be the one figuring out whether SPSS has divided your data, divided your items into 7 components, 7 dimension, even though originally there are 5. So you shouldn't follow SPSS in terms of 7. Yeah, but that's another thing, that if SPSS, let's say you think there are 5 items in one component, 5 items in another one, and then SPSS, what it does, SPSS removes one component from here, brings it to another one. That's a part. I'm sorry, you'll have to accept it. But if you think your overall concept is based on 5 dimension, not on 7 dimension, then you should not be following the specifics, you should be following the conceptualization. I hope I'm able to answer your question.
Thank you so much. I have another question.
Sure.
That why we get negative reliability and how to fix it?
Okay, negative reliability cannot be fixed. Let me tell you first. If it's a negative reliability, that means the data is extremely not reliable. Now, why it happens? It happens again because the respondent, didn't really understand what what you were asking them. So, what you want to do, the best strategy for me, if that's my personal strategy, doesn't mean that you exactly follow it. You don't need to follow it. I find that there is something wrong with my instrument, there's something wrong with my respondent, there's something wrong with the way I present it in front of them, there's something wrong in the environment they took it, there's something wrong with the design of my instrument. So I'll try to find the problem there, that this is happening because of this. So it's a negative reliability, that means there is no reliability. Forget about positive, it's a negative, that means there's absolutely no reliability. Your respondent has no clue what they're doing. They don't really understand what they're doing.
Next question, Muhammad Hussain. Yeah, you already raised your hand. Muhammad Hussain.
Thank you for giving me the opportunity. My question is it possible to run the multiple outlier test without using the mean value? I mean, using the main value, not the mean one. Thank you.
Okay, can you repeat? Is it possible to run which one test?
Yeah, I mean, is it possible to run the multiple, for running the multiple outlier test without using the mean value, not the main value? You can.
Okay. Actually, I tested, if you realize, I tested on item, right? So you can do on the mean value as well.
Yeah, Doctor, you just use the mean value, yes? But my question is,
item, right? You can do an item as well. You can do an item.
Okay, thank you.
Very simple. The software will do whatever you ask it to do. You just need to know whether am I doing the right thing or wrong thing. Software doesn't know. It will just run anything that you're giving it.
And another thing, I would like to request my participant, before asking the question, you may introduce yourself. For example, my name is Mahadisan. I'm living there. Like I'm doing that. It's better. We love to hear you. We love to know about yourself. So we could know you. Okay, thank you. So any question? And Nikhil Multan, NICL, Nikhil Multan. You can ask a question.
Hello, Dr. Kashif. My name is Amar. I am from Pakistan.
Yes, Mas. How are you doing?
Can you hear me?
I can hear you, yes.
So you did a normality test where you were showing us values of kurtosis and the other one. But in the same test we had a different value of KLM. So
what's the question?
How is it possible that the two tests have different results?
How is it possible? What do you mean by that? Explain your question so I understand that.
According to normality test kurtosis, we were fine that our data is normal. While the other test showed that it was not normal as the value was below 0.005.
Yes, true. Yes.
So why is this that the two tests have different outcomes?
Because it's just like that. Very simple. So you and I go to a restaurant to have lunch, right? You love the lunch and I don't like the lunch. Does that mean there's something wrong with the lunch? Not really. It's not really. It's how I am perceiving, how I am assessing the taste of the food, and how you assessing the taste of the food. So that means the same data. Well, let me just complete it. That means the same data, two different type of calculation, two different type of perspective, two different scholars, and according to one scholar, very stringent. Somebody's running Shapiro and KML, very stringent test, very stringent, very tough to get through these, and they're showing it's a non-normal data. The other one is showing it's a normal data, skewness, kurtosis. We do not trust all of these. Let's take a look at histogram. Visually, we can assess which one is normal and which one is non-normal. And histogram is most reliable. I guarantee you on that. Just check. Histogram is much more reliable than Shapiro and anybody. Histogram is showing me whether my data is normal or not, and we figure out at least one of our variable was non-normal, slightly non-normal. So why it is? Because two different calculations. Very simple. Two different perspective, two different way of measuring similar phenomena.
So we can use any one of them.
I would go with histogram. I would stick to histogram. For me, histogram is much more reliable than any other test.
Okay, thank you.
Right. So if my Shapiro, my KML, and my kurtosis, all skewness, kurtosis, all are showing it's normal, my histogram is showing non-normal, I will know my data is not normal. I won't trust the number as much as I can trust what I'm seeing myself. That's the idea.
I have another question. Can this be due, as we are using SPSS, can this be the fault of the software or?
No, I don't think that. That's not the case. What you want to do, let me help you with this. A couple of free softwares out there. There's one called Jamovi. Just download Jamovi. And I've given you the same data. I've shared, I believe, Dr. Media's email or provided on the group to everyone. So run the same data with Jamovi, or run the same data, just go to find any online data cruncher, any online data software. Free software, there are many online free softwares available these days, and run these analysis. And as far as KML and Shapiro there, you will find 99%, 98% same test, same results. There will be it's not the fault of software. And there is no fault actually. This is we call the variation, and that's the beauty of the world. We all think differently, we all assess things differently. So two different tests are assessing the same phenomena in two different manner. As a result, according to one, it's okay. According to the other one, is not okay. Now it's a researcher that has to decide which one is most reliable and which one serves their objective of the research better.
Okay, thank you.
Right? So you want to run the same data I've shared with you, online, and you'll find the Shapiro and Kimmel will get the same results. I'm pretty sure it will get the same.
Also, Dr. Kahsif, can you write your email here? Maybe some of you
Sure.
they would like to contact you. Maybe you can
Sure.
write your email here.
Let me write my email. I'm writing it. gmail.com. Kahsif.farhat@gmail.com.
Yeah.
I hope now everybody can see it. If you have any question, any problem that I know about it, I would love to share with you. But something I don't know, I will let you know. Listen, I know this much, but it needs to be further investigated. Right? Okay. So
Yeah,
let's.
Hi, Doctor. This is Fauzi from Malaysia. Just to
Yes,
just to continue to ask about this common method bias you have shared just now. You know, it's very dangerous when we do analysis. Then we found that something's wrong. Then we have to go back again, right? So I plan what usually we do is I think we use a marker variable technique then to do away with this. So when we collect this data as a marker variable, how do we analyze it in SPSS or we don't analyze it in SPSS?
No, in SPSS, to the best of my understanding, can I do marker variable in SPSS? I can. There is a way to do it. Hierarchical regression. When I'll be doing hierarchical regression, remind me. I haven't done it, but I think I can do it. If I use
it's a
hierarchical
good topic.
regression.
Yeah. So I think if you let's say marker variable is a method to actually do away with this, because we can get caught or later on we have to find out. It's very difficult. So if you do marker variable, then if you can do analysis in SPSS, when you do the smart PLS, it's going to be very easy for the whole thing. Yeah. So that's the plan.
I personally think, Fuzzy, I think it's very easy to do marker variable in Smart PLS or in Amos. So why to go anywhere? Just go to Smart PLS and do marker variable there. But I think I can do marker variable. I'm not sure how much accurate it will give me the result, but I think I can do using hierarchical regression. I can do marker variable in SPSS. I think I have to again check it and test it whether it's doing the same or not. Okay.
Thank you. All right.
Okay, somebody cannot join. Dr. Mehdi, have a look at somebody is not able to join. They're writing easy bro. Okay, let me go back to my slide. Dr. Mehdi, am I?
Yeah, you can start. Yeah, you can start.
Okay. So let's go back. Share screen. Let me share my screen so you can see it. Screen. No. Okay. So. Okay. So now we'll be. Let me. How do you hide it? I can't hide it. Why can't I hide it? Okay. So now, descriptive. So we're done with this part, data screening. Now we are going to descriptive analysis. Now, descriptive analysis usually, if you look at it, even in many of you, if you're doing your thesis or dissertation research, you'll often see that this is it's important that we do some type of descriptive analysis. Descriptive analysis are actually some of the very basic tests and basic type of statistics that we run. So let's go here. Now let's bring it here. Okay. Okay. So let's go here and let's do descriptive analysis. So for descriptive analysis, I'll go to analyze and I'll go here, descriptives. Analyze, descriptive, and descriptive, right? And then what I will do, I'll take again mean value. Again, I'll take mean value. I can do with both. If you're interested in this, let me show you. Both are quite helpful, mean value or without mean value. So let's select here. Okay, so I'm leaving everything there down, here, and then mean, standard deviation, minimum, maximum. I need variance and I need skewness and kurtosis as well. And continue and then style. Okay, don't worry about anything. That's about it. So let me show you again. analyze, descriptive, and descriptive. Okay, and then I came here, I selected all my items, not the mean value, and on my age, education, demographic data, gender. Then I went to option, mean, standard deviation, minimum. It's up to you. You want to take some, you want to take some. I don't like that one. Range, maximum, standard error, whatever. Okay, I'll just keep it as it is, and let's go back. Okay, let's take a look what happens. Now it has created a descriptive statistics for me. You remember in thesis, and some of you probably have already done it, and if not, in chapter 4 or chapter 3, depending where you're putting, in chapter 3 and chapter 4, in one of those chapters, you're required to put your descriptive, table. And your life becomes quite easy if you do it here. All you have to do is copy and paste in Excel or in Word, and you'll be able to format it right there. Likewise, what we can do, so we know that descriptive, this is where we're talking about descriptive. And look, number of total, right? And it says 207, that means I'm still using some missing value over here, right? Nonetheless, forget about it. Now, minimum and maximum, this minimum maximum is very important, very important. See, if you mistakenly, if you put anywhere on your sheet 12, 15, 19, typo error or 0, let's say, it will catch it. So if you see 0 here, let's say here, oh, some of my data, instead of putting 1, I put 0 there. So you need to go back to F23 and identify where is that 0, right? Likewise for 5, if you mistakenly you wanted to type 5, but you ended up typing 15, it will catch it here. It will show the maximum value. Okay, then the mean value, all the mean value, the standard deviation value. We understand what the standard deviation is. And then variance value, and then skewness and kurtosis if you want to. I personally find this option extremely useful in SPSS. It saved me from making or doing everything manually, and then making those descriptive tables manually, whether it's for my research, whether it's for my thesis, whether it's for any purpose. Life is quite easy. All you have to do is just set up your data in SPSS and just click descriptive, and bingo. Right click and it'll be there. Okay. Now I want to show you a couple of more things. You see, there's a lot of things, there's a lot of graphical things you can do. Let me try to do it here. Okay. Oh, I can't see. Probably okay. Let me bring it down back. So what if you wanna, let's see, you wanna show the standard deviation, for example. You wanna show standard deviation. So what you wanna do is double click. Oh, okay. And you just want to plot the standard deviation on some type of data, on some type of graph, right? Can you do that? I can't. Why? I'm not sure. Okay, so let's. Okay, why it's not doing? I'm not sure. Usually when we do, okay, now I can see. So that's how it's there. So let's say I select these. What it does, it shows me here, and now right now it's not showing me. It shows me here a type of where I can make table. I can make different type of tables. I'm not sure why I'm not able to see here. Let me see. Okay, I'm not sure why I'm not able to see. I know that we can do in SPSS, but we can also do here. Okay. Never mind. When we'll go to regression, we'll try to do it there. So we are done with descriptive. We're done with descriptive. And let's go back and take a look at. So I want to do these graphical charts. I'm not sure why it's not showing right now. It does. Okay. So what is the next part? So we're done with descriptive. We know descriptive table, how to make it. And the next is correlation. Now, many of us also run different type of analysis, whether it's AMOS or structural equational or regression. And often one of the basic assumptions is that there has to be correlation. There should not be high correlation. Likewise, there should not be extremely minimum correlation. Especially if it's a reflective construct, there should be correlation. So let's go back and let's run correlation in our data and let's see how they run it, right? Okay, pivot table. Okay. Let's do output. Close it. Okay. So now we'll do reliability, and then we'll do first we'll do correlation, then reliability, and then so let's go to analyze correlation, analyze, correlate, and bivariate, right? And if you remember, especially the one with the analysis, the one we're doing it, they remember they're supposed to provide. Before they run their analysis, they're supposed to provide a correlation table. And look what I've done. I've taken again mean values here, mean values, and I've put them here. Correlation, I've selected Pearson. I can do Spearman as well if I need to. Pearson is the one done. And then one tail. It's up to me if I want to take two tail or one tail. Most common is two tail, and then flex significant correlation. Leave as it is. You don't need to do anything and just run OK. Just run OK. And if you look at here, okay. See, this is showing correlation between these variables. So CSM, that means customer satisfaction relationship with what? Customer satisfaction has one relationship one. Obviously, it's going to have 100% relationship with itself. Now it has 0.73 relationship with FQ, PV 508, MV 598, 6.38. There are multiple arguments, but the most common one, the one I find is minimum correlation should be 0.20 and the maximum should be 0.8. Even though some people say, it can be up to 90%, 0.9. I believe that the most common one is minimum 0.20. There should be correlation between variables, the one you are running in your data, the one you are checking in your data, and the maximum should be 0.80. What do we mean by minimum and maximum? If it's minimum, if it's less than 0.20, essentially you will not be able to run many analyses such as regression, stepwise regression, and ANOVA, because eventually all these stuff.
Hello, হ্যাঁ আমি বাসায় রুমে হ্যাঁ বলো না আমি সেমিনারে আছি তো সেমিনার শেষ করতে আমার মাগরিব হয়ে যাবে
Yes. If it's going beyond 0.80 and if you really follow the other school of thought, which is 0.
হ্যাঁ রে পাটা দিছিলাম তো কিন্তু সেমিনারটা শেষ করি মাগরিবে পরে হ্যাঁ বলে যাও তারে খুলে আসবে তোমার ফ্রিজ থেকে জাল ভাই
Recording in progress.
Almost the same.
ও সেই তারিখ
You don't need to have both of these variables.
না আমি তো বুঝিনি যে তোমার যে হেল্প করছে সেই কেন
So if you just add them to same variable, means variable X and then same variable copy responsiveness. However, in our case, we see that none of our value, none of this correlation is less than 0.20 or higher than 0.80. As a result, we believe that the correlation test is justified. We can go ahead and run our further analysis. Let me show you there's another way to do correlation. There's another way to do correlation. Some people would like to run VIF value to run correlation. Analyze regression. Okay, so what I'll do, if I want to do, I want to check what we call correlation through VIF values. Okay, let's go to regression and then linear, right? Again, I have everything set up here, but let's see reset, just to show you again. I know independent, and this is independent, right? And I'll go to statistics, estimates. We don't need this. Model fit, we don't need this. Collinearity diagnostics. Just click on this. Continue, and let me show you again. Analyze regression. And then I went here, linear, and then I selected my dependent variables, and I went to statistics. I unchecked everything, and then just only select collinearity diagnostics. That's about it. I want to check autocorrelation through Durbin Watson, and now I need to continue. Okay. And if you look here, this is often you will see in thesis people report these values. If VIF value is less than 3.3 or 3, you should be happy. There is no multicollinearity issue, and so there should be correlation, but there should not be high correlation. And because there are multiple variables involved in this model, we call it multicollinearity. So if the VIF value is less than 3.3 or some say 3, then we can say there is no multicollinearity issue. Likewise, if the tolerance value is, I believe it should be below 0.80, something like that, then we can say there is no VIF issue, that there is no correlation issue. Okay. Let's go back and let's take a look at what we have next. So we are done with data. We have reliability, correlation, and VIF. Let's go to data reliability in Amos in what do you call it? Smart PLS. So let's do a similar thing. Actually, we're doing exactly similar thing. It's just that we will be doing. So let's check the reliability of our data. And notice I went to analyze, scale, and then reliability. And notice now I'm taking not the mean value. Now I'm taking this, because remember, the reliability is of the data we need to check, essentially in reference to scale. So let's select only these items, put them here, statistics, okay, and item, scale of delete. Look what I've done, again, analyze, scale, reliability. I came here, I selected all my items, not the mean value, never do it on mean value, it would be wrong. It's always done on this, statistics, then item, scale, and scale it deleted. Now, look what I'm doing, okay? Inter-item correlation, I don't need to do that, it's gonna be there anyway. Okay, and click OK. Okay. So this value you here see is the Cronbach alpha value. We all know the Cronbach alpha. We have an added option, CR, composite reliability. As far as I know, I haven't seen composite reliability here, right? So Cronbach, the problem is this Cronbach alpha value, this is for all the variables. This is for all the variables. It's for all the variables. So what we need to do, we need to go back and reset. We don't need for all the variables, we need for one variable, one by one. So we'll do one by one. So let's go back, analyze, scale, reliability analysis, reset, and let's say customer satisfaction. Customer satisfaction, and again, statistics, item, scale, deleted. That's it, continue. and okay. Now we have here for scale. Scale is what? Which one? Customer satisfaction. Now we know all these value, everything. Now the Cronbach value is 0.886. We know that if the reliability value, Cronbach alpha value is anything 0.70 or 708 is good enough. We don't need to do anything. Now look here. Look here. So if you wanna, so we see that mean value here, scale value, everything, and okay. So we understand that 0.886 is good enough. We don't need to do anything. But what if you want to increase our value? What if your value is less than 0.70? Then we have another option. It shows Cronbach item if deleted. So it's saying if you delete CST1, your value will be 8.52. If you delete CST2, your value will be 0.856, 0.869, 863, 865. What we're learning is that if whatever item we delete, we will never have as high value as 0.86. So we're okay. Our data is reliable. Our data is our customer satisfaction data for this. That's about. We just need to report for customer satisfaction this. Okay, let's go. Cancel. Okay, let's go and let's do for another one. Customer scale and reliability. We said let's do for what? Ambience. Ambience. We know the statistics is already there. No.
Scale item.
Continue and then again ambience is 0.87 and this appears to be the highest possible. Let's do another one. So we need to do one by one. Don't do it all together. Do it only on the item, and we only do one by one for each variable, for each construct. We do one by one. Let's do what? Responsibility, customer satisfaction. Let's say food quality. I don't know. I just want to see which one is the lowest one. Okay, so item scale deleted. Continue. Okay. This is again 0.869. And apparently, whichever item I delete is still, it will not include reliability. So we're done with reliability. We know how to check reliability. But the problem with the SPSS is that it will only show you, it will only give you the reliability for Cronbach alpha. To the best of my knowledge, I haven't seen, I don't know anyone. I have not seen anyone testing CR, composite reliability on SPSS. Okay, let's move on to the next. Okay, so I believe.
Oh, Kahsif, you are.
I believe most of us understand the difference between reliability and validity. While reliability is, if you can see here, I've drawn here. So you see the correlation here. This is what we're trying to prove, correlation. So we understand that reliable means that you always get the similar results, similar measures. On the other hand, we understand the validity means we get to measure what we are supposed to measure. So if we are measuring, let's say, the concept of techno stress or techno stress, then validity allows us to know that whether we are testing the right measure, whether data shows that we are testing the right measure or not, the right concept or not. Our items are showing that they are testing the right construct or not, which is if we want to do that. Okay, so we can do that through EFA and CFA. Now, I'm not going to go in detail, but just to show you exploratory factor analysis. This is the time exploratory factor analysis. We do EFA when we are doing, especially when we are developing a new construct. Usually we do CFA in Smart PLS and even in Smart PLS and AMOS. What we run is CFA, right? So remember the measurement model. Measurement model is actually CFA, component factor analysis. Right, outer loading, you call it outer loading, also called factor loading, right? So that factor loading or CFA are the same thing. Factor loading and CFA are the same thing. There is no difference. EFA is usually done when we are developing a new scale usually, Other way around, some people say if you have done any type of, there is another school of thought who believe that if you have done any type of what do you call adaptation or small changes in your items, we call adaptation. So then you should again be running EFA. However, I do not belong to that school of thought. I still believe if you have done slight adaptation, CFA is good enough. So I'll be running only CFA, not EFA. I'll just show you how to run EFA, but we'll be focusing only on CFA. Okay, let's go back. Let's go back. Okay. So how do we run EFA or CFA? We go to diamond reduction and factor. Diamond reduction and factor. And I'll reset it. And look what is happening here. Again, I will be taking items here. I'll be taking items here, and I selected all the items. I selected all the items here. Right? Factor analysis. Now, if I'm running EFA, this is fine. That's how EFA is run. All item in one place, and then you go to extraction and you tell this how many factors you want to make it. However, I'm not running EFA. I'm running CFA. For CFA, what I'll do, I'll go one by one. Customer satisfaction only, and I just need to make sure that it loads, right? It loads extraction, fixed number factor, 1, leave as it is, principal component, don't do anything. Okay, I believe that's the way it is. Not fixed one, okay, agent value is 1, okay. Continue. Oh, okay, sorry. And then covariance matrix. Yeah, I believe that's covariance. Principal component, that's the one. Covariance, principal component, and eigenvalue 1, and continue. Let's see if I got it right. Okay, I just need to make sure my rotated component matrix, where is rotated? I just need to make sure that rescore component, these values are above 0.5, right? These values are above 0.5. So rescale one is all these are above 0.5. So that means my each outer loading, so in other words, these are outer loading that you see in Smart PLS, a factor loading, here we call it factor loading. All these values are fine. All these values are above 0.5. And the newer way they say in Smart PLS, we say no, it has to be 0.708 and above. However, for regression, if you're running the older way, people used to do 0.50 and 0.60. Really up to you which school of thought you want to follow. For me, if I'm doing the regression, any value is above 0.50 is fine. I don't need to worry further about it. Okay. Okay, sorry. Analyze, again, let's do it with another one. EFA, factor, reset. Let's do the last one. This one. Responsiveness. Again, descriptive. I don't need for this. Extraction, margin value, fine, covariance, okay, okay. Again, these values are 0.87, 863, 847. Let me do it other way. Let's see how it comes out. Analyze, just for my own understanding, extraction. Let me force it to 1. Let's see what happens. It remains almost the same. Okay, so likewise, so if you wanna do reliability, so what we do in regression, when we're running simple regression or any test based on regression, we should be doing reliability and validity. For reliability, we should be doing Cronbach alpha. For validity, we should be doing factor loading, or in other words, outer loading one by one, and we should be reporting for all items in our model. Okay, so let me close it now. So we're done with what? We're done with data EFA and CFA. I gave you the option. Okay, now we're down to the crux. We're down to crux of our workshop today. So I believe you all understand type of models. I guarantee you most of us understand type of model. We understand the direct relationship right here, and then we understand the moderated relationship right here, and we understand the mediated model here, and then we understand moderated mediation model. And some people call it mediated moderation. Eventually, it's the same. Let's call it moderated mediation model. Okay, so this type of model we can run easily in SPSS, no problem. And this type of model means multiple regression. Multiple regression, the direct relationship. However, when it comes to moderated and mediated or any other variation of this, we cannot run unless we have another software called unless we have unless we have another software called process macro. So what I've done, let me show you, let me go back to my SPSS. This is what I've done. Look here, analyze. I've installed an extra software here called Process Macro. It's a free software. You can simply download from the link I've given and just go to the website. It will show you how to install it, and you will be able to run not only regression, we can simply run regression from here and various type of regression. But when it comes to running mediation and moderation within regression, then we need to install this free plugin, free add-on we call Process Macro or Process by Hayes. Okay, so going back here, so we understand this, the only directional relationship can be run easily, no problem. When it comes to moderation or mediation or any type of moderation mediation, we need Process Macro to run it because SPSS itself doesn't have this option. Okay, so number one, we will be doing multiple regression, OLS, ordinary least square. And in order to do that, multiple regression means we'll be doing the first model here, only direct relationship. So we'll be doing multiple regression, OLS, and we need to understand that whenever we run regression, there are few assumptions. There are many assumptions, but usually there are 5 assumptions that are most common. Number one, linearity. Number two, that means there's a linear relationship, right? Linear relationship means like this. This is a linear relationship, right? Even if it's positive or negative, it's a linear relationship. So our hypothesis should be linear. We believe that there is a linear relationship we are testing. One. Number two, no endogeneity. I'll just leave it. Just remember it has something to do with the we call error term. Anyway, so, and the other one is called homoscedasticity, and the third one is no autocorrelation, and the last one is multicollinearity. We've already tested multicollinearity. We know if your hypotheses are linear and linear. Homoscedasticity and autocorrelation, I would suggest all of you to just go and Google and YouTube, and you will know how to do it. I can show you how to do it. Again, it's just going to take a lot of time. We don't have much time, so I'll just move faster. Let's run multiple regression, and then we'll run hierarchical regression. Let's do it one way. Remember multiple regression for the direct relationship. Okay, let's go. Let's go to regression again and linear. Let's reset it here. We know, okay, we'll be taking again mean value, customer satisfaction, our dependent value, and these 4 variable, which means FQ, food quality, perceived variance, ambience, and responsiveness of customer service team. That depends. We believe these 4 are able to predict customer satisfaction. Let's go to statistics, model fit, R-squared change, we don't need that. Covariance metrics, let's put it here. We don't need collinearity diagnostic. We don't need plot. We don't need any plot as of now. We can do that and just run it. Just run it. Okay. So here, number one, I'll have to probably go. Here, number one, we see dependent variable, right? Regression results. We see the dependent variable says that whenever we'll run any type of analysis, SPSS shows us what it has run. It gives us the details. It's showing me the variable it has run. It's showing me the method. It's showing me which one is dependent, and so much and so on. Now this is the model summary. That means altogether, all four variables, responsiveness, perceived value, food quality, ambience, how much, when we ran it, how much they are explaining the dependent variable, which is customer satisfaction, according to them, is explaining 0.793, which is the R-square value, right? So this is the model which is explaining. Now, let's take a look at here. Okay. Okay. I have made a mistake. I'm sorry. Let's go back. Can I see that? Yeah, it's right here. So I was looking for, I am struggling with this. Okay. So here we see how much the R-square is explained, 0.793. Likewise, we have a NOVA value. However, we are interested is usually model summary we are interested, and then we are interested in this. We are interested in this, right? And if I click on R-square team, I believe I'll be able to see another value here as well. So let's take a look at each of one by one. So we know FQM, the food quality has a significant relationship with customer satisfaction. Perceived value has a significant relationship with customer satisfaction. Likewise, ambience and likewise responsiveness. All these variables load significantly. Why? Because these values are less than 0.05. We never really focus on constant. We always focus on these values, and these are values. So we can say that our model, okay, we should have a significant value here as well. Nonetheless, that shows the model fitness and the overall model. Nonetheless, usually our hypotheses are here where we say that the food quality has a positive impact or has a positive relation with customer satisfaction. And if that's the hypothesis, we know this hypothesis has accepted. Right? Okay. So this is, we call a regression, and it's also called multiple regression. It's also called OLS, ordinary least square regression, right? Now, what is ordinary least square regression? It's a type of regression, one of the most common one of the most famous one. Okay, let's go next. What is the next? Hierarchical regression. Now, what do you mean by hierarchical regression? Okay, let's think about it. Let me close it and go back. What if we have, let's go back to regression. What if our argument is this, listen, we're saying that we know that customer satisfaction, we want to understand customer satisfaction, and we're also saying that we know that customer satisfaction and food quality and food quality and perceived value, relationship and responsiveness explain. But we also believe that the gender matters here. We believe that, in other words, we're talking about the control variable, if you remember, control variable concept. We believe that it may change. We believe that it's not across the board. We believe that we need to control the effect of gender, and then we need to see if the effect remains same, if these all four relationships are still significant. So what we'll do is this. Next, we'll check this, and let's put it to stepwise. And again, let me show you what I did. I went to analyze, I went to again regression, and then I went to here, then I went here, and I took my dependent variable. I know my independent variables are these. I put them here, and I believe that we need to control, or we believe that there is some type of interaction going off age, and if this is the thing, gender. So what we want to do, we go to next, and we add gender here, and we change method to stepwise. Let's do it stepwise, then we'll do it without stepwise. Okay, and that's about it. And then go to statistics, and here model fit, confidence interval, We don't need right now. We can do that content interval, but then R-square change is very important. The rest looks okay. We don't need that. Okay, now run. Okay. Look what happens now. Again, it's showing me what I've done. Now it's showing me two models. It should show me two models. Okay, let me get out of it. Let me get out of it. Okay. Stepwise, no, we shouldn't be doing the stepwise, should be in the middle here. Regression, linear, enter, okay. Yeah, we should be doing one, not stepwise, we should be doing this one. Look what I did. I ran the same model by putting gender in the box too, and look what it did. It's showing me, let me show it close. It's showing me two models now. The first model as it is. Yeah, can you guys please turn up your mic? Okay, thank you. Okay. Now it's showing me two models. Number one model, look, as it is, as we run in multiple. Dr. Mehdi, can you please turn off the mic of this?
Yeah, I did.
Thank you. So now it's showing me model 1, and see that model 1 has the same variable, and model 2 has gender as well. So what I need to do is, I need to check the R value, 66.3. So we are saying that these four variables altogether explain 66.3% dependent variable. And then however, when we add it, and that's a significant one. If you see the F value is significant. However, when we've added gender here, how much change is there? So the change from R square from 0.663 to 0.667, it looks negligible, but let's take a look at the F square value, F change value, and it says 0.161. So now we can say that the gender has no effect on our results. Gender has no effect on our results, or our results with gender, without gender, doesn't matter. This relationship, what we have tested here, is the same. That means gender has nothing to do. These four variables, responsiveness, perceived value, food quality and ambience, have a strong relationship with customer satisfaction individually and even collectively. So we're done with two parts: multiple regression and hierarchical regression, right? Let's go next, mediation and moderation. So now in mediation and moderation, I'll try to do these three types of, number one, simple moderation, number two, simple mediation, and number three is moderated mediation, right? Okay, so let's go back, let's close it here. Go to analyze, I'll be using the same data, again, regression, and if you remember, I just discussed with you guys, I shared that earlier that I have installed a free plugin called Process by Andrew Hayes, and I've given the link of this from where you can download and install it in my slide that I'll be sharing with Dr. Mehdi after this session. So let's open Process. So Process looks like almost the same as regression, and again we'll be taking the mean value. We know customer satisfaction, and number one will be running a simple. We'll be running a simple moderation. Simple moderation, yes. So let's go to CSM is Y variable. This is what we want to predict. And we know that FQ, so which one we want to take moderator? So let's say FQ perceived value, variable, perceived value, X. Okay. Remember one? Okay. Yeah, simple mediation. And I can't, if you look, I can't put 2x here. I can't put 2y, only one. And I'll be talking about that in a while. Okay, and let's say that ambience is the moderator. Ambience is the moderator. We are saying that, we are saying it that customer is satisfied as a result of food quality. However, we believe that the ambience in the environment they sit, that has an effect on their mood as well. So we believe that it's another independent variable. We believe it's a moderator. It moderates a relationship. If it's a good ambience, we believe it has a good impact on customer satisfaction. If it's a bad ambience, we believe that it decreases customer satisfaction. So it moderates the relationship between food quality and customer satisfaction. And look here, I've taken only one variable here, only one dependent variable, only one moderator here. Okay. Now I'll go to options here. And it says show covariance metric, regression, no problem. Generation code, visualizing interaction. Yes, I need that. No, this is for mediation, pairwise, indirect effect. Let's put it this way. Let's leave it standardized coefficient. Test for M, residual. Okay, just leave it as it is. This standard deviation. Try to use this. Most people use this. This is where it looks better. Effect size is only for mediation and pairwise. I can do it, but just forget it. So just leave it. So I'm just selecting these two, and if I want to do pairwise, I can, but I'm just leaving residual correlation. I'm not just doing it. Let's continue and let's okay. So in this, we have one dependent, one independent, and one moderator. Let's hit OK. It's gonna take a while. Just wait. Okay. So now, just like earlier, we can see what we have run here. This is the model here, and we see the sample size model 1. And look, we have outcome variable is showing that outcome variable. And now let me make it a little smaller and let me show you what it means. Look, this is the total model is showing us the R value and the P value. So the total model says the total model, if we add, if we consider total model, then this is significant, and the R value is also very high, 0.76. However, if you understand that, we are interested in direct relationship, but we are also interested. I'm sorry, why I have to keep moving. We are also interested in this interaction effect. This is where we're interested. And look here, it says product keys. We are interested when FQ and A and B, when they're multiplied, how much effect they create on customer satisfaction, and whether that effect is significant or not. And look here, if you look, that effect is right here. So we know the direct relationship FQ on this. This is the coefficient value, and this is the P value. This is significant. Great, we know it's a significant. A and B is a direct relationship. No, it's not significant. And then we look at here, coefficient here, and coefficient C error T value, and we see that P value off. So it shows that ambience is not interacting. The ambience doesn't have a significant, interaction effect, significant moderation effect. If you want to prove it's a significant, it should be less than 0.05. Right, and why it is, because you see that ambience itself has a insignificant relationship. It's bigger than 0.05. So as a result, we can't prove there is moderation going on. There is a moderated relationship between food quality and customer satisfaction through ambient, at least in our data, right? So okay, if you want to look at this, it's pretty good to understand where it is. However, we'll just move on. We'll run now simple mediation. Okay, so let's run simple mediation. No. Okay, let's bring it down. Analyze. Okay, for simple. Okay, there is one mistake I made. Let me go back. I think I made this mistake. I just need to check. Wait. Did I make this mistake? No, I didn't make that mistake. So we are fine. We did well. It is important thing that when we are doing simple mediation, I am selecting model 1. I'm selecting confidence interval 95, and I'm selecting 5,000. This is extremely important. Extremely important, don't get it wrong. So for this, I've selected model 1, and I'll be sharing a file to show you why I'm selecting model 1. So this is model 1. Now for simple moderation, let's do simple mediation. Now for simple mediation, let's reset it. I'll be selecting model 4. And again, simple mediation means only one variable as an independent, as only one variable as a dependent, only one variable as a mediator. So let's say customer satisfaction again as our y variable. Let's say food quality is our independent variable, and let's say responsiveness of the staff is our mediation variable. We're saying that food quality is good, but food quality turns into perceived value. Okay, let's take perceived value. So we're saying food quality results into perceived value results into customer satisfaction. If this is a variable, I'm taking 4 here, and look, I cannot put here, right? Okay, so I'm taking only those 3 here, and model 4, confidence interval 5, and now I'm doing mediation, and look, I'm taking show covariance metrics of this, generate code for visualizing interaction. I don't have interaction here. I have right, and I have pairwise, and I have mediation, effect size, test for interaction. I don't have the interaction. That's about it, and I'll put it here. Some of these are only for mediation, some of them are only for moderation. We just need to read it and continue, and then okay. So now our focus is mediation, non-moderation, and according to that, we have selected the right model. And this is the challenge in process. You have to tell the process that which type of model you're running. It has a number, and I'll be showing the sheet I have to show me, that shows me which model, what type of model, what kind of, what number of model you have to select. I have a whole PDF available, and I'll show you in a while. Again, going back here, the model is showing here, model summary is right here. However, what we are interested, specifically what we are interested is we call indirect effect. Can you see the indirect here? Indirect, right here. This is indirect. You see the indirect effect is right here. Effect size is this much. Okay. So the problem with this indirect effect is here, that with indirect effect, you will not see those p-value. Rather, you will see, let me go back to indirect effect. Okay, you will not see the p-value, rather you will see these both UL, that means upper limit and lower limit. And the rule for upper limit and lower limit is that if you want to establish whether there is mediation going on or not, we just need to look at these lower limit and upper limit. It's also called confidence interval. Actually, these are confidence interval as far as I understand. There should be no zero between these. So between 0.0511 and 0.165, there is no zero between, right? So what if there was, let's say if there was minus 0.0511 and then 1.01654, then there is a zero between. Then we would say, oh, our hypothesis is rejected. Now we're accepting our hypothesis because within these values, lower LLC1 and LLC1, there is no zero. But if there's one value is minus, the other value is in plus, then there is in between, there's a zero, and then we'll say our hypothesis has rejected. So in this case, we believe that there is a mediation going on. Perceived value is mediating the relationship between food quality and customer satisfaction. If that's true, let's move on to next one. Okay. Now I'm moving to the last one that we call mediation, moderated mediation. Now, how to do moderated mediation? Let's go to again analyze, regression, and then linear. Oh, sorry. analyze, regression, and then process, or reset it. And this time again, I'll be checking what my customer satisfaction is same. And now which one I want to take moderation? Which one I take? Okay, let's take the same. So let's take perceived value as a mediator, and let's take food quality as this, and let's take ambience as a moderator again. So now what we are doing is this. What we're doing is, let me show you here. So we are saying is that ambience is affecting the relationship between food quality and perceived value. This is the relationship we're doing right now here. And then what if your question should be, what if this moderation is not here, is actually here? For that we have a different model, and I'll show you the sheet. For that we have a different model. So if that's the way you have set up your hypothesis, we'll just select as it is, and now I'll be checking many things here. Show covariance regression, yes, generate code for visualization, even though I'll not be running, but the code shall be there. There's pairwise, let's say pairwise effect size, test for X interaction, that's about it. And again, standard deviation here, continue, rest I leave here, model should be 7. Model number should be 7, and that's about it. And click OK. That's going to take a while. We'll have to wait. We're done. We're down to the last one, and we're almost done. And whatever time will be left, we'll be doing our question and answer session. And after that, probably Dr. Nidhi will be taking some pictures of this, and that'll be the end of our workshop today. Okay, again, so now we understand that. So number one, this is the one we're saying here. Okay. So number one thing, whether there is a interaction going on or not. Now let's take a look at interaction effect, coefficient, right? P-value. Oh, there is no interaction. Why? Because our p-value 0.65535 is saying there is no interaction going on. Let's take a look at there's another thing we can take a look at. I don't remember, but I'll have to really find that. There's that direct effect and indirect effect. Now, if you want to see, okay, so we know the interaction is not going on. What if you want to see the indirect effect? So indirect effect, okay. So we see the indirect effect. The mediation is still going on. So when the ambience was 2.08, 2.00, we see the mediation was there. When the ambience was 0.123, still mediation was there. When the ambience was 4.0027, still mediation was there. So mediation at all levels, the mediation is still there, but the moderation is not there. And how I determine mediation? By looking at LLC1 and LLC1 value and ULC1 value. Because all of these values, none of these values between low and high, and again between low and high, there is no 0. So we can say that mediation is still going on, but the moderation is not going on. Okay, that's about it. I believe it was helpful for you guys. Let me show you a couple of more things. Let me first close it. Yes. Okay. Yes. Okay. No. Let me show you a couple of more things. I have another file here. I'll show you various models of process. So how do you know which model to run? Now, because you have a variety of models. So what Hayes has done, he has also provided us, let me close this. Hayes has also provided us a list of models, and I'll be sharing with this Dr. Mehdi as well, so he can share with you. So here's provided us a list of models, so which model to run for what type of analysis. So saying model 1 for this type of analysis, you can likewise for model 1, you can run for this type of analysis. What if you have this type of model going in? You have 2 moderation, they're saying it's a model 2, right? And like, model 4, we just did simple mediation. What if you have this type of, where you have two type of, two interaction going on here and here, then you should be selecting model 5. Okay, and this is the way you'll be selecting, and this is the way they are saying, statistically they are showing the model, right? So you should be focusing just on this. What if you have serial mediation, 2 mediation going on? Okay. What if you have this type of model? So altogether, there are many models, right? I obviously can't go through all these models, but that's the way it is, and you just need to select your models accordingly. Lastly, just the last thing, let me close it. Just the last thing with all of you. You need to understand, we need to understand that what we have done here is that we have done regression. If you are doing this process, if you're using process, remember, you're not doing a structural equation modeling. You're not doing it. You're doing regression. A structural equation modeling is different from regression. There's sometimes the results could be quite similar, but these are two different. Pure regression and structural equation modeling are different. Structural equation modeling, it has some component of regression, but it has many components which do not involve regression. So if you're doing this process, keep in mind you're doing regression. Whether you're doing mediation moderation, but keep in mind you're still within regression. But if you're doing, if you want to do specific structural equation modeling, I would suggest you don't look at this. Don't look at this. Don't use this process. Then go for Amos, and then go for any other software that has structural equation modeling. Don't use. But if you don't care about structural equation modeling, you just want to run mediation and moderation, and keep in mind even some of the top publishers that are accepting, they have no problem with process. You can run process, and let's just keep in mind when you run process, don't call it structural equation modeling. Likewise, when you run structural equation modeling, don't say the process and structural equation modeling are the same. No, they are not, and the results could be different. Okay, no one is better. They all are good. It's really up to you, whichever you want to use, right? Last thing, I want to show you a book. I have the book here. No, I don't have the book. I wanted to show the book. I have the book. Where's the book? Okay. Process macro. I have the book. Okay, where's the book? No, I don't have the book. I thought I had the book here. Introduction to Mediation Moderation. No. Okay, there is another book called, and I'll be sharing the book with you in a while. That book is extremely helpful to understand all this process, and actually even to understand research and how all this is happening. The book is by Hayes, and it's called Introduction to Moderation, Mediation, and Regulation Approach. And I'll be sharing with you in a while. Let me close it and let me hand it over to Dr. Mehdi. Dr. Mehdi, thank you very much.
Thank you very, very much, Dr. Kahsif,
Recording stopped.
For your valuable space and time. Now, we would like to know our participant opinion. So, can you turn on your camera? We would like to see you, and we would like to listen to you.
Okay, somebody's asking me, is customer satisfaction or scale, ordinal scale? No, customer satisfaction is a ratio scale, continuous.
Now you can ask the question. If you have any question, you can ask Dr. Kahsif. Also, it's time to...
Dr. Mehdi, thank you so much for a great session today, of course, and Dr. Kahsif Khan. So thank you so much for your valuable session. Actually, we have learned a lot about SPSS today. Thank you, and please do not forget us once you are going to organize another sessions like this. This is really very lovely and valuable for us, of course. Thank you so much.
You're welcome.
So anybody else you would like to say anything?
Okay, we have one more question. It says, dear sir, my question is that how can we justify the values of mean of computed variable subscale, because many people ask me about how did you calculate mean? it should be between minimum 1 and maximum value 5. They could not understand that it is the calculated mean of factors variable. Is there any way to clear this to reader? I think they were not aware of this analysis. Very simple. I am taking, the problem with regression is that regression doesn't take the weighted score like Smart PLS does. Regression can only be run on one variable, on single value. So what we're doing, we're taking simply the mean value. And how I'm taking the mean value, let me go back. Wait, let me show you what I did so you understand. Let me show you what I did. Let me open my let me open my Excel sheet. Let me do it in front of you. This is what I've done. Whether I do an Excel sheet or I do it in my SPSS, I can do it both ways. Simply, I'm taking the mean value. Why I'm taking mean value? Because this is what the regression requirement is. Let me show you how I do it. Just give me a second, Dr. Mehdi. I'm really sorry. Question is like that. I can't.
Yeah, sure.
Question is like that. I can't do it verbally. Look here, brother. Whoever asked me, brother or sister, whoever asked me this question. So let's say I am taking you. I believe you can see all my sheet. Insert here. Okay. So I'll be taking average value here, average or mean value. So let's take mean value. Let's remove this for a while so I don't take, it doesn't come in my deal value. So let's take average. Okay, and I'm telling this to take average of this. I'm sorry. Let's take average and go here. And I'm telling Excel to take average here. And then I double click on it. Okay, double click on it. It's really up to me if I want to keep this way or I want to see other way. Okay, so that's about it. This is what I'm doing. We're taking mean value, very mean value. If you don't like to compute in MS, what do you call SPSS, you can simply compute here and take this value directly there. This is the mean value we are doing, brother. And it's a problem with the regression. Regression cannot take, at a time cannot take this. In other words, SPSS doesn't have this ability to take the data as what we call psychometric scale, automatically convert into mean value and then run the analysis. It doesn't have this ability. And there is a reason it doesn't have this ability. What if you don't want to do that? Because for various things you need to do it without this. However, you can do it in structural equation modeling because structural equation modeling takes weighted score, not the mean value score. This is the difference. That's why structural equation modeling probably is a better way of doing it. Probably, I'm not sure. Okay.
Sir, excuse me, sir.
Yes, madam. Yes.
Sir, without regression, we can also report simply mean values, ST values, factor-wise. If I want to report the mean value factor-wise,
you can.
So,
yeah.
I can. And sir,
yes.
Okay, sir.
Yeah, regression is the last stage. It's all these mean value, factor value, reliability value is the preparation to run regression. So you can do it. If you don't want to run regression, you just need to check the reliability and the factor value and the mean value. You can do it, no problem.
Okay, sir. Thank you so much, sir.
Yes, welcome. Any other question, guys? We are short of time. We have only 5 minutes, so probably 10 minutes left. Any other question, relevant question, I'll be happy to answer. If I know something I don't know, I'll let you know. Listen, I don't know.
Also, you can on your camera.
Yeah, please turn on your camera so we can take a picture.
Yeah.
With your smiling face.
Sure.
Wasim is smiling, I can see.
Yes, doctor. Thanks for your really fruitful presentation, and we learn a lot from this.
Okay, thank you. Thank you very much for joining us today.
Thank you.
Sananbek, thank you very much for coming out today. I'm glad you joined me again. We did last workshop 2 weeks ago, and you're here again. Thank you very much for coming out.
Thank you. Thank you.
Also, any suggestion? Do you have any suggestion for us?
Yeah, it's a wonderful, fruitful presentation, and I'm looking forward for these type of sessions in future as well. Next time, try for a MOS as well.
You want to learn a MOS? Well, actually, Dr. Mehdi already did a MOS, right?
Yeah. So
Or
I
maybe
can do it if you want. I'll have to review
Yeah.
things. Long ago I used a mouse 2 years ago, so I have to review everything.
Also,
I kind of like Smart PLS, and there are other softwares, Jamovi and GSM. Oh, they're better than more. Just try it. See how powerful those software are.
yeah. Thank you. Anyways.
anybody
So,
else?
if anyone would like to ask any question, I can answer. If not,
Yes, sir.
please, Lubna, we already conducted the session Smart PLS. Dr. Mehdi has given the link to his, what we call YouTube channel. Kindly subscribe to that, and you'll be able to see my Smart PLS, workshop that I conducted 2 weeks ago. Dr. Mehdi, please share the link of your channel. A lot of people would like to have.
Yeah, sure.
Right. Somebody else would like to ask any question. If not, Dr. Mehdi, please request everyone to turn their camera on. Let's take a picture and conclude this session.
Yeah. Can you turn on your camera? And also, you can introduce yourself, because some of you I don't know. Also, we don't know. Can you say anything, a few words? Jins, Jos, Yusra, Omea from Thailand. Can you say something? Yusra Omene, is it? Omane. Also, this Jos, Jin Jos. Wahudi.
Assalamu alaikum, everyone. Thank you, Dr. Kahsif Khan. Thank you for this session. I gained too much knowledge on this SPSS. Thank you. If I have any question, I will ask in your YouTube channel, right?
Sure, and I've also shared my email address.
Yeah.
If you wanna do that, you can.
All right. Thank you.
Email me. I've already shared my my workshop PPT file on the chat, and Dr. Mehdi will also be sharing the same file.
Sure.
All right. Thank you, Doctor. Thank you. Assalamu alaikum.
And anybody else?
Thank you, Doctor. It was really a wonderful session, and now we have to, with whatever the data you have provided, we have to try with the SPS software and see. And if you have any doubt, we will get back to you. I have noted down your email address. Thank you so much, and hope to attend more sessions like this in future.
Sure. Thank you. Thank you, Dr. Rabia, for coming out. Thank you very much. I guess, Dr. Mehdi, you want to have a picture, right?
Yeah.
Please, everyone, turn on your camera, please. If you're comfortable, please turn on your camera. Dr. Mehdi, I think you'll have two views. One view and second view.
Mr. Tuhid and Mr. Saiful Islam, thank you very much. Can you take some picture?
Sure, sir.
Yes, sir. Already going on. And also special thank you, Mr. Saiful, and also Mr. Tuhid. Also, special thank you, Dr. Kahsif, for his time, valuable input, and everything. Also, anybody want to say anything?
Sir, I can say something regarding our
Saiful, carry on.
Because at the beginning, I want to again thanks a lot for our we are really happy to get him again and again. I hope because already we know that his generosity, because he always try to do something for the new scholar and new researcher. Already we observed by these 2 consecutive programs. So I hope that our honorable professor, Dr. Kahsif sir, again will help us and always spread his hand to our new scholar. So this is my request to our honorable person, as well as again thanks to our research cave founder, Dr. Mahdi Hassan sir, because his unconditional effort to upload our new scholar. This is really amazing. So we can just give a clap for him, from all of you. Thank you, sir.
Yeah, hello.
Yes, please. Yes,
Yeah,
James.
I'm very, very grateful for the insightful presentation you've made. You have actually increased the knowledge base, and for that we say well done. However, we would actually appreciate it if you can share with us the PowerPoint slide, the material you used in your presentation. It will do us a lot of good, and we look forward to other insightful presentations from you. Thank you very much.
Yes, thank you very much, James. Thank you very much for coming out. I've already shared the PPT slide in the chat of this Zoom meeting, and in case you're still not able to access it, Dr. Mehdi will be sharing in the group.
All right, thank you.
Dr. Mehdi, how about the pictures? Have you taken? Your mic is off, Dr. Mehdi.
I think some of our team members, they're supposed to take some picture, and I will later share with you.
Okay, sir.
Dr. Kahsif,
Yes.
Dr. Kahsif Khan.
Yes.
I am from Sri Lanka. Actually, this is the first session for me regarding SPSS. Very useful, actually. I got some rough idea. Inshallah, in future I will continue. Inshallah. Thank you so much for organizing. But the Mahdi Hassan also.
You're welcome.
You're
welcome.
Assalamu alaikum and hi to everyone. Dr. Kahsif, it was very fruitful presentation. Me from Pakistan and from Malaysian, I get much more knowledge in different sessions. And in your leadership, I suggest something that as we are all the social scientists and we are getting some knowledge from different perspectives about SPSS and research, I request all the participants that if we make a group and we did some research activities or research publications, that will be very valuable. As we all members are representing our country, so the different people can make a group in your guidance, in your leadership, and I think that will be too much fruitful.
Right, Dr. Mehdi has already created a group. Dr. Mehdi, you created a new group, right? PhD Grow something, right? So why don't you create the link for that and share in the chat?
Yeah, sure. Yeah,
because with our original groups, I think those are specific to UUM students. So let's open it up for everybody.
Yeah, okay, no problem. They're supposed to have a link, and you can join there, and you'll see there's a lot of people from different countries. It is around 20 countries people are there. So maybe you forget to click there, the link. Could you check again and you click there and join here?
So Lubna is asking for that link. Can you put that link again? Do you have that link? Can you put that link in chat?
Sir, we will share our yes.
Yes, Islam.
Okay. We will share in our WhatsApp group as well as Facebook group and YouTube group, inshallah, within a short period of time.
Okay, I guess that's about it then, Dr. Mehdi. If all is good, there's no question, I think we can just conclude it. It's almost time 6 here in Pakistan.
Yeah, once again, I would like to say thank you very much, Dr. Kahsif, for your time, for your available space, sharing knowledge, and thank you everybody. Also, we'd love to see you again. So try to connect with us, Dr. Kahsif and me, and our. There's also a WhatsApp group, Facebook group. So you can join our WhatsApp group, Google Classroom. You can join there, and also Dr. Kahsif already shared his email, so you can try to contact him if you have any problem. Also, you can write us. We'd love to see your opinion.
Yes,
you
you
know,
can write me.
You know, one thing is very important in the research academician. You know, two heads are better than one. So it means we should work together. And also there is another theory, you know, synergy theory. Synergy theory means 2 2 makes 5. So what? Yeah, if you 2 2 makes 5, it means sometimes if you work from different field, it makes diversity. So in academia, if we work together, so it can be create what I would like to say, some better network. We can share our knowledge. Is it? So don't try to feel, don't try to hesitate. Share your any idea, anything.
Right. Rightly identified and said, Dr. Mehdi. Actually, in our last from our last session, I've received at least 2 to 3 queries on my email, and they have been quite frequently asking the question, and we're trying to respond back to them. So yes, if you there is no charge to it, so all for free. If you have any question, any problem, you can come and share with us, and whatever we know, we'll share with you. That's the way we'll learn. Okay, thank you very much, all of you. Thank you very much for coming out. Thank you very much for your time. I'm sure I was able to, I hope and actually, I believe that I was able to add some value to your learning.
Is sure he was able to? Okay.
That's about it from me, and hope to see you in next session whenever Dr. Mehdi organizes.
Well,
Okay.
Can I have a suggestion?
Yeah, sure. Please, yeah. Can you write your WhatsApp or email, then we'll contact you.
Okay, I think this forum is very good, and I hope that after we have joined this kind of meeting for several times, we have mastered some statistics, science. So I think in the future we can do a kind of research. We can collaborate. We can write articles with some researchers coming from different countries, and I think it will be good academic cooperation between our researchers, especially for us, for the beginners who would like to write some research. And I think we can publish using different names coming from different countries. In the future, it will be very good action, I think. Thank you very much, Doctor.
Welcome.
No, you are welcome. So anybody else who would like to say anything? If you don't have any query, any question, any opinion, any feelings, maybe we can, we are close to end.
Okay, take a picture.
Yeah, you can take the picture and share with your Facebook and anywhere. You know, around 30 countries people they register for the workshop. So I know many of them, many of the people, and also Dr. Kahsif also know.
Yeah.
So I did, you know, during my PhD, I did around 20 workshops, and also I know there at least 30. I know Mr. Khan, he know Sanan. So you may say anything. So we manage a lot of people from different countries, and I know if we see the people face, we can read because we already spent this time. So once again, I would like to say thank you very much, and thank you, Dr. Kahsif, and all of you, and I'll see you again.
Thank you very much. Take care, everyone. See you again. Bye-bye.
Okay, goodbye.